This is a video for AQA Further Pure Mathematics, Matrices section 5.1, which looks at invariant lines and introduces the idea of eigenvectors and eigenvalues. We know from previous videos that 2x2 and 3x3 matrices produce linear transformations. We also know, of course, that whatever the matrix is, that the origin 0, 0 will be equal to 0, 0. And therefore the origin maps onto itself, and straight lines through the origin must therefore map onto other straight lines through the origin. So to study this, we can look at a vector in the direction of a particular line. So for example, the line y equals x has a vector 1, 1 along its direction. So if I've got a particular matrix, such as 2, 5, negative 1, negative 4, I can see what happens to the line y equals x by looking at what happens to the vector 1, 1. And if you look at that, it becomes 7, negative 5. So therefore we can see that the y value must be negative 5 divided by 7 of the x value in all cases. Or in other words, that we have the line which is 5x plus 7y is equal to 0. Here we see that again, this time with a graph showing us the vector 1, 1 and the image of that vector, which is 7, negative 5. So that the line y equals x is mapped onto the line 5x plus 7y is equal to 0. Now let's consider the same matrix 2, 5, negative 1, negative 4, but multiplied by the vector negative 5, 1. And when you multiply that out, you'll see that we get negative 5, 1. Or in other words, the vector has been mapped onto itself. And we can say that it's equal to 1 multiplied by negative 5, 1. Therefore, the line it represents must be an invariant line. Similarly, 2, 5, negative 1, negative 4, this time multiplied by the vector 1, negative 1, this produces negative 3, 3. But that's negative 3 times the original vector 1, negative 1. So again, we've got the vector is mapped onto a vector in the same line as we had originally. So both of the lines represented by these vectors are invariant lines. We talk about these particular vectors as being eigenvectors and the scalar multiples as being eigenvalues. So here we see that again with the multiplications firstly, and then a graph showing you the effect of that. So the original vector there, 1, negative 1, mapped onto this vector here, negative 3, 3, but obviously in the same direction. This in fact is the line y is equal to minus x. The second vector is mapped onto itself, so both the original and the image are here, and so the line must be mapped onto itself, and that line is the line y is equal to 1 over negative 5 multiplied by x. Or another way of saying that is that it's x plus 5y is equal to 0. The vectors that map onto scalar multiples of themselves, so negative 5, 1 and 1, negative 1 in this case, are called eigenvectors, and the multiples eigenvalues. So in general we say that if M is a square matrix and V is a vector such that we have M multiplied by V, that's the matrix multiplied by V, is some lambda multiplied by V. In other words, we've got the vector multiplied by a scalar value lambda. Then V is an eigenvector and lambda is an eigenvalue. Then the line in the direction of V is an invariant line. Well, of course, in the examples we've just looked at, I gave you the eigenvectors and proved that they were eigenvectors by doing the multiplication. But in general, of course, we want to be able to find those eigenvectors for a given matrix and the corresponding eigenvalues. And that's what we will do in the next few videos.